Okay, I will send you all the file. Okay, these are the file I will send you all in zip. Okay, I haven't complete yet because I only complete your PSO. Okay, which is particle sum optimizations. That part I complete already, and then I also complete the location, the optimum location for this PV, not PV, sorry, BESS, okay, BESS location. So I highlight few things here, and then I have two important paper you have to read related on what you have to do. Now, I just want to explain to you before I go into the coding on what I did in the coding. So let me explain to you in this whiteboard here. Okay, so what my program does is like this. Okay, first I will go through what it calls collecting the data. Okay, collecting the data from 39 bytes. Okay, okay, this is the first thing. Okay, but of course your one is 14. Okay, so from this number one. Okay, this is what my program do lah. Okay, you see. Number two is compute the 14 bus. Okay, from this 39 bus. Okay, so what you are going to see here is a result optimized, okay, using the GA, genetic algorithm. Okay, genetics algorithm. Okay, so you will get something like the optimum solution for the power lah. So the plot will be something like this. Okay, one is a reference, something like that, and then the other one will be optimized. Okay, optimized solution like this. So this is a bus, number of bus. Okay, and then versus the power in PU. Okay, this is the power. Let me show you here in PU. Okay, now the best this is something like minimizing the power. Actually, this is the optimized power. Okay, so what you will see here is because my iteration is 39. Okay, 39, and then you are focused on the bus 14, right, somewhere here, right? So you will see that when you do the optimization using this GA genetics, so what you will see that is you will found something very interesting is uh, you will get the optimum solution at this point here. Of this point here, it give you the minimum power. Okay, to minimize the power loss lah. So you look at here, and then this is your location. This is the location of your PV lah. Okay, PV or BESS. Okay, something like your DG lah. Okay, something like PV. Something like your DG. Okay, distributed generator. But I call it a PV BESS lah. So at this particular bus here, then it will give you the best optimized power based on the graph. I will show you later on. Okay, then after that okay, after that your the program will generate the program. Okay, compute compute this what it calls a correlation. Okay, now this correlation is important because you need to plug into the PSO, which is particle sum optimization. Plug it into the PSO. So this will going to lead you to see the accuracy. Okay, because the PSO you have to understand. I read all the article. Is the interesting part is it always reach the target of 0, 0. That means there's consider no error lah. Okay, so you see you move something like this. This is the Y and this is the X. So there are so many particle pop swarm. Okay, pop. At the end, they all meeting at this point here. So I assume that at this point is already optimized. Now you play with the correlation, and I noticed that if your correlation from your result optimized result and best result in between 1 to 2, then is okay. Okay, It's okay. So all your point, all your swarm particle will meet at this particular point here. Okay, I highlight it lah. I highlight it. Yeah, at this point here, exactly. On the other hand, if you have a correlation coefficient which is more than 2 or less than 1, so your swarm particle, you will not focus at this point. That means there's some error. So you will focus somewhere here. Okay, so this is what I do. Okay, now there are two things I haven't do is the one you mentioned with PV and without the PV. That part I haven't do yet, but the data I already created. So I just want you to check on this part and give it to your supervisor. Okay, now let me show you in MATLAB itself. Now this is the program. Okay, this is the program basically is talking about here. Okay, up to here 1 2 3 4. Okay, so let me show you how to run it. So you just run. So you will plot a few graph. I think 4 graph. Okay, one of it is important. The rest is for me to check the accuracy. So you wait for some time. Okay, so wait okay, I need to record the screen, and then this one we call optimum power loss and the location. Okay, so this is the active power loss minimization using the GA is your genetic algorithm. Okay, so you will take some time because iteration need time it will take computation time. So you can see that this is the result. Let me show you. Okay, this is the data, bus data for 39. Is extract from here. Okay, this here. But don't go and change this one. This one I took it from IEEE. Is a standard one. So when you do this computation, it will take all the data from here. Okay, so this is a graph. Let me explain to you later on. And then this is the actual per unit power, and this is the optimized power value. And then you want to calculate the correlation, you just type correlations, then just type, and then you just press enter, and then this is the correlation already. Now because you are focused on 14, right, so you can use Excel or anything a calculator. You just calculate the 14 on this, you take average is roughly about close to 1, 0.98 something okay. So now before I take this correlation data, put it into your PSO, let me explain the graph first. There are 4 graphs. This is the one which is very important to look at your location. Now you can see that there are 2 graphs here. One is a power best case, another power for optimum solution. So when you talk about the optimum solution, we are going to target this point here, which is at the sharp point. Okay, so at this particular point, okay, you can see that. So here is roughly about 14. Okay, that means your location of BESS is at the 14 bus, and then here's another one. Okay, is somewhere around 3. Okay, so I think you can put your pointer point to here. I think here it will show you the number. Yeah. Okay, so this is number 2. Okay, location at the bus 2. It give you the optimum power. Here also, okay, location at 13. Okay, not 14, sorry, it's a 13, something like that okay. Now related to the coefficient, okay, coefficient here, right, and then you add them out 14 and then divide by 14, so you get close to 1, and then you plug into the PSO. This is the PSO. Okay, particle swarm optimization. So this PSO here, you key in your correlation somewhere here. Put somewhere here. Here, this is a correlation. Okay, this is a result. So you put your result here, correlation. Okay, take from here, calculation here at the result here. Okay, so you put it here. Now you run this PSO. So you will see what happened. The result, you get something like this. You see that? You will focus all your particles will focus at this point here, which is 0 and 0. That means you already optimize the result. Okay, optimize it. That's why you come out like this, right? So correlation factor is very important. Now let's say, for example, if it's not within this 1 or 2, somewhere around 4, Then you see what happened. Huh?